Hi students, I'm Nazar, and this is Practical Science. Hi students, welcome to Practical Science. It's been a little while and it's time to have a bit of a look at a galvanic cell. This method is one that was shown to me by Liv Belshorvac down in Jindabyne, and so a shout out to Liv, and also to Jacob Strickling, who I explained this problem to, and he's created some absolutely beautiful resources out of the tiny science kits to help us to demonstrate the principle of galvanic cells. This is basically what batteries are. A single cell is basically two different metals where there is an electron exchange from one metal to the other. And the difference with a galvanic cell is that if we connect an external wire, we can actually get the electrons to run through the wire from one metal to the other, that is from the anode where oxidation is taking place, to the cathode where reduction is occurring. If we can separate those two reactions, then we're going to be able to hopefully generate a voltage. Now, not only that, we can generate different voltages by using different combinations of metals. So today we're going to look at copper, magnesium, zinc and iron. I'm going to set these up in a simple galvanic cell. Measuring cylinders with 5 mils of water. Transferring that into each of these little bottles. Okay, and that's because I need to make some solutions, 1 mole solutions of everything. What I need to do here is I need to tar this, and then I'm going to get my potassium nitrate, and I've measured out, I've calculated 0.51 grams. That's my 1 mole solution of potassium nitrate. So I'm going to leave that there, and then I'm going to do the same thing with all 4 other solutions down here. So then the next one. There's our copper sulfate, 1.21. That's zinc. 1 to go. All right, now we're good to go. So to set up our galvanic cell, first of all, we've got these beautiful little templates that Jacob has cut out for us. So I'm going to put in the little cardboard one and then the piece of filter paper. So the filter paper is hopefully going to be really good at picking up our solutions. So what I'm going to do is I'm going to, first of all, I need an electrolyte. So I need what is equivalent to a salt bridge in other galvanic cells that you may have set up at school. And to do that, I'm going to use some potassium nitrate. So here's my potassium nitrate solution. So what I'm going to do, first of all, is I'm going to put that on the center of my little cross. So let's put a couple of drops there. And so that's going to run down. That's very nice. So now what I'm going to do is I'm going to test, first of all, I'm going to see if my iron works because I'm not confident with my iron. So let's try the iron. And then I want the iron solution. So I'm going to get a little bit of my iron nitrate. Go just 1 drop this time because the 2 drops has saturated everything. So pop that there. Okay, these are 1 molar solutions. We made them up earlier. You saw me do some of that. And so that's our standard solution for galvanic cells. So let's try that with some zinc. So here's the zinc. So let me pop the zinc over here. Now for the zinc, I need a separate pipette. So here's my zinc solution. Some zinc. You can see that now we've put together our little 4 metal galvanic cell apparatus. We've got iron, we've got magnesium, we've got zinc, and we've got copper. So now I need to add my electrolyte. So my electrolyte is the potassium nitrate. So that functions as a salt bridge. It allows the ions to move from one metal to another. So let's just pop a little drop in the middle. And then what we need is a solution of the ions of each of these with their metals. So zinc with zinc, some iron, then we have copper, and finally some magnesium. Now let's just see how our little galvanic cell goes. All right, so to test the galvanic cell, what I need to do is to touch these and to focus in on the voltmeter. So let's try magnesium with copper. All right, so there's a value there that looks like about 1.2. I'm going to stay with magnesium and I'm going to go to zinc. It's a small number. It's maybe 0.4. And the iron is maybe about 0.8. So you can see that some of what we've got is not very accurate. I'm going to swivel this around a little bit so I can get to my zinc. Try the zinc with the iron. So a little value there, maybe 0.2, and with the copper, a little value, but not quite what I would expect. And I'll just try the iron and the copper. So we've got a little value there as well. Small amount of voltage that we're producing from this teeny tiny little galvanic cell. It's a very small scale version of a galvanic cell. And of course the best result we had was from the two metals that are furthest apart electrically, which is the magnesium and the copper. So you can see our little galvanic cell. It's very simple, but it works. It's a great little example of electrochemistry in action. For my salt bridge, I'm just going to soak this in some. So what I'm doing is I'm just soaking the potassium nitrate filter paper in my electrolyte. So this is going to be my salt bridge. So it's the classic salt bridge. I'm going to use, we have the zinc. It's the iron that's there, and the zinc is here. So the zinc is our little zinc salt bridge. All right. Now, the moment of truth. Can we get a reading on our voltmeter with this salt bridge? So that's a galvanic cell. So a multimeter would give me a more accurate value, but you can see I've got a nice little reading. It's a good value. If I switch my terminals, I'm going to get a negative value, so that I don't want. But there's a nice little positive voltage which has been created by the connection of this galvanic cell. So one of the things we talk about in science is accuracy, and we've got sometimes the opportunity to replace an analog device like our voltmeter with a digital device like our multimeter. So we're going to repeat this experiment just very quickly with the same parameters that we had before, but this time we're going to take each of our measurements using the multimeter. So we're using exactly the same materials as we used before, so that means we need to set the galvanic cell up the same way. So I need my salt bridge. So again, I'm going to use some potassium nitrate, and then I have some copper and iron, some magnesium, and then finally some zinc solution. And so this makes sure that all of the metals are in contact with their own ions in solution. Now let's see if we can measure each of the galvanic cells using our multimeter. All right, let's try magnesium and copper. All right, let's try magnesium with iron. I'll try magnesium and zinc. Now let's try the zinc with the copper first. So the zinc is a bit problematic. All right, that's pretty good. How about the zinc with the iron? Alrighty. And then finally, let's do the iron and the copper. Now you can see if I actually reverse the polarity. So let me try my largest value, which was my magnesium and my copper. You can see how the value is a negative value, which is actually telling me that the current is running in the opposite direction. So one of the good tests to make sure that you've got your galvanic cell connected up correctly is to see whether you have a positive value or a negative value. And if you do have a negative value, you just reverse your electrodes and you can see that value coming through. So there's some values for the digital version of exactly the same galvanic cell.